In this next question, we're asked to determine the inverse of the function shown algebraically, then to graph the function and its inverse, and then state the domain and range of both. Well, we begin by letting y be f of x, so that we can make this statement right here. We're then going to switch x and y, including a let statement to let the reader know there's been a fundamental change. So we're going to say that x equals negative 3 times y minus 3/4 squared plus 2. Now we're going to solve for y, and we're going to remember our order of operations. We are going to subtract 2 from each side, then divide each side by negative 1/3, or in other words multiply each side by negative 3. We're then going to take the positive and negative square root of both sides, and finally add 3/4 to both sides. Letting that be f inverse of x, we get our final statement for the inverse to be f inverse of x equals plus or minus the square root of negative 3 bracket x plus 2, and then all of that plus 3/4. Well, we go now to our graphing, and we see that the original function given, the downwards opening parabola, is rather wide, looks like that. And when we reflect it in the line y equals x, we get that rather wide sideways opening green parabola. On first glance, we might say we're glad that we had the blue one to graph the green one, but of course we didn't need it. We could have just thought in terms of transformations. We could have thought of that green curve as two different curves, one of them with a positive a value, one of them with a negative a value, but the k, d, and c values are all the same. Either way we think of it, we're now able to determine the domain and range of both the original function, the blue one, and the inverse, the green one. Well, the domain of the blue one is x element of the reals, and the range is y less than or equal to 2. Looking at the domain of the green curve, we see the domain is x less than or equal to 2, and the range is y element of the reals. And like we knew we would, we have a situation where our domain of our function corresponds precisely with the range of the inverse, and the range of the function corresponds precisely with the domain of the inverse.